Our next speaker has over 20 years of experience in film and digital workflows and has honed his expertise in managing the entire production process from on-set camera implementation to post-production deliverables. Presenting AI-powered cloud automation in HDR, mastering for next-gen media, please welcome the Director of Solutions Engineering at Colorfront USA, Brandon Heaslip.
Afternoon, everybody. Hope you're all having a great Simp Eve. I'm going to get right into it because a lot of this is obviously slides, but you definitely need to just come over and see what we're doing in our booth to actually get a full impact of all the tools that we're demonstrating and talking about here at the show and going forward. One of the biggest things going forward is obviously utilizing the cloud infrastructure from AWS that we're a great partner with for all the various workflows, specifically in QC. A lot of the big things that we do that nobody else does is we redirect files from S3. So that could be your Red, your Sony, your IMAPs, your DCPs. So you don't need to virtualize your storage. You can actually get access to the media as quickly as possible in order to start doing the QC process, whether for your OCNs or for your mastering side of the workflow. And with all the different deliverables that everybody has to do these days, the more that we can load up the front end to speed up that pipeline, the faster everybody can get their content delivered. This is a very basic drawing of what we do. Obviously, it's a system in AWS with G5 or G6 instances. And then with that, one of the big things that has come across over the last 5 to 6 years is my media is in the cloud, but how do I see that at the same quality that I see it inside my facility? And so we've developed using SRT HEVC. You can stream from any of our products, whether it's Transcoder or QC Player or Onset Dailies, directly to your facility or through the Colorfront Stream Management System, a reference quality stream at anywhere between 10 megabit to 50 to 60 megabits per second in order to do real-time QC from the cloud. And we recently introduced the ability to do caching locally. So the stream will arrive from S3 and from AWS at your facility. And when you press pause, that interaction and go back a couple of frames or go forward some frames is the same interaction that your QC operators would have as if they were operating from a local PC or a local system from their SAN or their NAS inside the environment. We have a corresponding software on the receiving side, which is called the Streaming Player. And what that does is it captures the fully encrypted AES 256-bit encrypted stream, and it's all certified to make sure that it's as secure as possible. We've got forensic watermarking, visible watermarking, all those things that as a content creator and or owner, you want to make sure are there to make sure that your material is completely secure along the way. So now getting right into the QC portion of things, one of the things that we've discovered is more and more things on the QC world. The turnaround times for QC is getting shorter. So what used to be 3 days or 4 days for the turnaround are now coming down to 12, 24, 48 hours in order for a facility to get a piece of content, QC it, and then get it pushed off to the studio or the OTT platform for the next step of the entire workflow. And with all the various HDR, SDR variants that you might have to do, you want to make sure that the master file that's being QC'd is as perfect as possible. So we've got a lot of new tools that we released or improved over the last 6 months. We move very quickly. Just to name some of them, so we've got the ability to import CSVs and marker tracks from third-party solutions. So if you're doing something like a Baton report, we can actually take that CSV into our software, whether it's Transcoder or QC Player. It will show up as markers on our timeline that your QC operator can then jump through to check and confirm and enter into the QC system along the way. Then we also have a new automatic framing detection. And what that does is it's going to look at the overall frame of your picture. Say it's a 239 image, and it's going to scan and look for any errors at the edges for things that might move over a frame or two based on an encode that showed up or a last-minute VFX plate that dropped in. We find that this kind of makes it through QC, not because the QC operators aren't highly skilled, but because on an OLED, how do you know where the black frame of the OLED ends and the black frame of the picture begins? So this tool allows you to see those edges, zoom into them, and you can actually report them back as errors. You can let it go through, just to get that going to everybody down the line. We also just introduced a new black frame and repeat frame detection. So if you're playing back, hypothetically there could be a bad encode where it repeats the frame, and a QC operator might not necessarily catch that. A lot of the good ones do, but sometimes it falls through the cracks. But the earlier you can catch these things, the better. We also have a black frame detection, so if it drops out randomly when it shouldn't, whether it's intentional or not intentionally, we now catch that. We have our loudness checks that we've been doing for quite some time now. Then we also have a new dead pixel detection and subtitle's the next one, dead pixel and sparkle detection. This works on both OCN and also finished content. We've actually found dead pixels in released content that you didn't catch, whether it was in VFX or across the entire pipeline. Then we've got our subtitle detection, a rolling credit analysis, which use a combination of what we call Tamash AI, our lead engineers' algorithms, along with LLMs that we feed into it with the information that we generate in order to see what is text or not text in the process. And then we've got video comparison, compression quality measurements, improved Dolby validation tools, and a new customized file tool, which I'll explain in a second. So after I've now just listed these, I'm going to show you some screenshots. Again, the best thing to do is come over to our booth before the Solution Hub closes. We can actually show these in action. It's a little bit more, impressive than just a single slide. So what the file validator does is you as a studio or a content creator can create a custom file that the QC houses or even yourself can run all the content that comes through against it. So if, say, everything that gets delivered to you needs to be our one time code inside, before it even hits the QC process, you run this check, and it can be driven by an API. And when it does that, it'll say immediately, like, oh, this file is not our one-time code. It's immediately rejected. You can send it back saying, we're not even going to do a visual QC because we already know your file has failed the very first basic check, which is a lot of the metadata things that happened. And they can be very simple for ProReses, and they can be very complicated for things like IMFs with your MCA label tagging and your color tagging. The next thing is our loudness and audio detection tools. So this is a loudness tool that we have inside of the software that I always forget is it EBU 128, I think is the standard for loudness. I forget which one they are. There's many of them. But we have that built into the software that looks for any of it does the average loudness measurements and checks. And then we also have a new audio dropout detector. So sometimes in encoding, audio will randomly just drop out. We now have the ability to detect that. And again, all these tools are API driven. So you can front load a lot of the workflow before the QC operator actually sits down in a QC bay. We have the frame light level analysis, which obviously does your max fall and max CLL. Your max fall and your max CLL, one's the average, one's the brightest peak in a specific given piece of content, whether that's an IMF, DCP, or ProRes, which inherently has spikes that hit it in the encoding process. And then we've worked really closely for a very long time with Dolby to implement a whole lot of Dolby Vision toolkits. We obviously have Metafire built in as one of the checks that we do with the Dolby Vision metadata. But one of the big things that we do that separates us is we've built a lot of custom tools for validation that are beyond the scope of the Metafire. Metafire is to make sure the XML itself is good, but it's actually not looking at all the detailed content. So we've actually got a variety of new tools. One is the L6 sanity check. There's also one that does a scene detection analysis. So what happens a lot with Dolby Vision is your XML will be delivered to the mastering house based off an XML that came out of a color correction. And the color correction has, hypothetically bars and tones on the front of it. And that has in the XML the bars and tones metadata, which is normally null and void. But in your mastered piece of content, it does not have bars and tones. You've removed that. So when you drop the XML into the timeline, you see a whole bunch of errors, not just one or two where the actual cut point of the Dolby Vision and the actual content cuts. It's offset, but there's like hundreds of them across your content. And typically what you end up having to do for that is manually look at each one very painstakingly, go back to the post house that gave you the XML and try to figure out what was wrong. What we allow you to do is actually slide the Dolby Vision metadata on the track of the transcoder or QC player timeline and line it up with the scene detection that we've done underneath. So you can actually offset the two XML, the actual cuts with the XML, slide everything into place. And in my example, it's a 240 frame offset because I have bars in front of my content. So I slide that over, and now it's all lined up, and I can say, okay, the XML is now lined up and good. But then the very next day, they give me a new XML because they've made more trims, they've made some changes. When I bring in that new XML, I don't need to do that process again. I can bring that XML into the transcoder, and it remembers the offset. So when you drop it on the timeline, it immediately lines up, and you can continue down the process of generating your content as well as exporting a new XML down the line to help speed up the workflow, because we found out most of that is done very eye matching and manually, and it's a very painstaking process to do that. One of the big things that we did as well for IBC is, so again, it's just a still image. It doesn't make a lot of sense unless you see it. We have a new subtitle detection tool. So what we have found is there is a lot of content out there that has burned in subtitles that content owners would love to remaster into Dolby Vision, into HDR. But the problem is when you do that with burned in subtitles, the subtitles end up being like 500 nits, burn out everybody's eyeballs, and you can't really watch it. And to fix that is more or less impossible without a lot of money and a lot of time. So what we end up doing is we've built a model where we actually analyze the material, and then we feed a bunch of TIFF files that we take where we find the RGB values that match the subtitles RGB values. Once we make the TIFF files, we feed that into the Tesseract model to tell us what's text and what isn't. Once we know what is text and what isn't, our software understands that when I apply the ColorFront Engine up mapping node to go from, say, SDR or XYZ to 1,000 nits, it will up map everything, including the subtitles. But then we have a new tool called the Subtitle Manager, where you drop that in the node pipeline, and you can pull the subtitles down without affecting the color or the creative intent of the full up map from the SDR to the HDR finished piece. And so you can actually upmap a burned in 48 nit DCP to 1,000 nits and then pull the subtitles down and keep them in that 100 to 150 nit range, so you're not burning out everybody's eyeballs without roto and all those other tools that you need in order to do that. The next thing that we also introduced is a rolling credit detector. So it will read through the rolling credits, and it will give you an SRT and a text file of what is in the credits, and you can compare that to, it's a complicated world of PDFs and text files and Word documents, but we heard from a customer at IBC that 90% of their rejections are rolling credit problems. And so we built a tool in order to help facilitate speeding that workflow up, and we'll continue to build on top of that. And then another tool that we have that's not listed here is we've introduced speech to text. So we use the Whisper library in order to read or listen to the content, and then you can make SRT subtitles out of that, deliver it back, edit them, fix them, and then bring them back in order. Again, all of this is about speeding up the workflow. This is a sample of a dead pixel detector. And so what we do is we analyze the media, again, whether it's an OCN, a ProRes, an IMF, and we look for dead pixels or groupings of pixels that seem to be dead. And what we have is a close-up of the what we call the the marker window, in order to actually go through each pixel, and you either give it a yes, a no, the severity, and you can actually knock through all the different dead pixels, or if it's just compression, you can ignore it. And the idea is you can get through those dead pixels, and then in the very near future, for some camera manufacturers, we'll be actually able to send back a new camera mat to the camera house, or the camera assistants to update the camera's mat. So then that pixel is not a problem anymore. And you can also relay that back to the camera team. Hey, you've got 4 more dead pixels than yesterday. We might want to take that camera out of the show and get a new camera put in. And so that's what that tool is designed to do. And then we have a similar, using the same marker window. This is a close-up of the framing detection that I spoke about earlier. And what you see on the far right-hand side is the yellow is the area of interest, and then the white line is the actual frame that we think it should be for, say, a 239 mat. And then on the close-up, you've got left, bottom, right, top, and you can actually go in and zoom in. And when you double-click it on one of the boxes where it says 0, it will zoom into that exact area, so you can actually see the offset. And you can go frame by frame, and you can see that the actual frame line bumps over a frame, a line or two over or under what you anticipated. And then what do you do with all of this? So we've built a new comprehensive media report. This is only just 2 pages. Typically ends up being anywhere from 2 to 15 pages. It will show with time code, with a thumbnail of your dead pixels, your repeated frames, your silence markers, your black markers. It'll show you the loudness, your max fall, your max CLL. It will show all this in a clear and concise PDF that you can pass down the line, deliver with the file, and then keep for your records. And then most importantly, I think is a lot of this is utilizing the tools that exist today and will continue to evolve over the next 2, 3, 4 years to speed up the workflow. QC operators are highly important in the industry, and what we need to do is utilize their skill set for looking at the material, catching mistakes, but we can front load all of these checks. I can run the file validation, I can run the dead pixel, I can run the max fall, max CLL, I can do all of this before the QC operator actually sits in the bay, sits down and starts looking at the content, and all of this comes with markers. And in order to facilitate that, all of the things that you just saw and much more can be driven by APIs or what we call web forms. So a web form is basically just a user GUI version of what the XMLs and the API calls are actually doing. So you can build these presets to say every piece of content that comes through, do this every single time, create a report, and then it can get put into your MAMs, PAMs, DAMs, all those various tools in order to keep and your databases to keep the workflow going. But right off the bat, if there's something wrong with a file that's going to cause an immediate rejection, you don't need to spin up the QC bay, you don't need to spin up the QC operator. And as there's more and more content being generated, anything we can do to assist the QC houses, the studios, and all the various people to get this content done and to market and into all the people that we make all this content for, the better. With that said, that's my presentation. I really thank you guys all for the time, and please come over our booth. We're right over there, and we can actually show you some of it in action. And hope you enjoy the rest of the show.